So to get started with, so today we're going to discuss about quantum enhanced Web3 wallet. So now traditionally, since I'll just give a background about blockchain and how it works, so that you'll be on point with the explanation. So currently there are two types of popular blockchains. I think you heard about Bitcoin blockchain, right, and then Ethereum, right. So today we are going to focus on more on Ethereum virtual machine, which is the current programmable blockchain right now, right. So when it comes to accounts, right, there are two types of accounts. One, an externally owned account, which is the traditional accounts, and then you have smart contract accounts. So when it comes to externally owned accounts, again, they're mathematically generated and which are not linked to the blockchain, and it will be only linked to the blockchain when we try to do the transaction. Let's say when we do the first transaction, that's when it's get linked, or that's when you can say that it's being added in a block in the blockchain, right? And in contrast to this, you have smart contract accounts. So smart contract accounts are again not traditional accounts, they are programmable smart contracts, in which case you can make it more configurable. Let's say if you want to have 4 or 5 people to be signatory authorities, in that case you can also do that with a smart contract account. Whereas traditional accounts, you will be having only one person who will be having the signing authority, or it will be a single account, right? So today we are focusing more on the externally owned accounts, and you can see, like I've mentioned, quantum enhanced, but not quantum safe or secure, because now we are trying to use quantum entropy, randomness from the quantum entropy, and then to make it more secure. Because let's say when I mention that I'm using, when I mention quantum safe or quantum secure, in which case I need to use random entropy from a QRNG. At the same time, I also need to be using PQC algorithms. Then I can claim, okay, it's more quantum safe or quantum secure. And since in this case, we cannot call it quantum secure or quantum safe, and now we're not trying to do it because Ethereum works on a different algorithm, and when we try to embed PQC, then the end signature algorithm changes. And since Ethereum is a public blockchain and it's already being in the use, so we cannot modify or change the core of the blockchain. So, and since these are, as I mentioned, externally owned accounts, which are again mathematically generated, so it's easy to make it more secure and more random in nature. Yeah. So to get started with the current traditional problem that we have, one, let's say when we talk about traditional Web3 wallets like MetaMask, for any user, when you're trying to create the account, when you create an account, there will be 12-word seed phrase which will be generated, and as a user, you have to supposed to store that when you want to recover the account, or when you want to log in on a different device or a different account, right? Which is very vulnerable. Which, let's say, for example, if you store it somewhere else and if you misplace that, then there's no way to recover the account. And let's say if that 12-word seed phrase falls into wrong hands, again, there's no way to control or recover that, right? And second thing is, randomness. So in the traditional wallets, the wallets are generated using PRNG or OSPRNG. But in our case, we're trying to make it from the QRNG. And what we're trying to do is we're trying to take from the QRNG and then the PRNG and mix it up. Why? Because like when you take the random bytes from the QRNG, and since it's hosted to the cloud and we're going to access it from the API, it can be vulnerable. Let's say if we lose the random bytes within the API, if it gets exposed, in that case, then we're going to compromise on the private keys. So that's the reason what we're trying to do is we're trying to mix the random bytes from the QRNG and random bytes from the PRNG, and then we're going to generate the keys. Right. And when it comes to quantum advantage, so as I mentioned, we're trying to take the random entropy from the QRNG rather than the PRNG to make it more complex or more secure. And when it comes to the verifiable unbiased, with the traditional PRNG, whenever we try to generate the wallet, or whenever we try to generate the wallets or accounts, there's no verification being done to check the randomness score or the quality. But since we're trying to take it from the QRNG, we're trying to check the randomness using the NIST algorithms, NIST scoring. And so these are the 4 components of the quantum enhanced wallet. One, the authentication layer, and then the quantum randomness, and then the MPCK management, and then the backup factor. So the first part is crucial. So this is going to change the user experience of the traditional wallet. So here what we're trying to do is, for this demonstration, we are using file-based authentication. But in traditional, you can replace that with custom login or custom authentication, or probably any social login provider like Google and Microsoft, right? So this we're going to use to manage the users. Let's say to create the users, to manage the users, and to manage the user sessions, the Firebase or any social authentication. And then the quantum randomness. So this we are trying to take the random bytes from the QRNG device, and then comes the MPC key management, multi-party computation. So here what we're trying to do is whatever keys that are being generated from the QRNG or the quantum randomness, here we're trying to split into 3 shares. So in which case, at any point of time, whenever the user wants to log in or sign the transaction, they would be requiring 2 keys as a minimum threshold. And MPC also going to make sure that okay, the private key is never reconstructed at any point of time. So in which case it's more secure. Let's say if you lose the private key, which means you lost access to the wallet. So MPC going to split the private key or the key generated from the quantum randomness into three parts, and then the backup factor. So as I mentioned, this MPC key is this MPC going to split the key into three shares. Let's say if you want to add more backup factors or more shares, again that can be generated from the quantum randomness and can be added. Yeah. So this is how the wallet works. So first we're going to authenticate the user either through email, password, or probably Google or any other social login, and then we're going to verify the identity of the user, whether the user is valid or not. Let's say if the user is the new user, in that case we're going to create the user and then we're going to manage. At the same time, then we will also manage the session of the user. Let's say if the user is trying to log in at from multiple devices, then in that case we're going to manage the session as well with the Firebase authentication. And when it comes to quantum entropy generation, here we are trying to use quantum-based QRNG, through which we are able to get the randomness through the API. And then for the MPC, we are trying to use a protocol called Web3 auth. Web3 auth is a protocol which will split the keys into three different shares and which will manage the key. In which case, it will ensure that the private key is never reconstructed, and it is going to manage the signing of the account and the user experience. So in this case, you don't need to maintain or store the 12-word seed phrase, but rather it will be very similar to email, password, login, just like how we do it with traditional wallets. So this is the architecture, for the entire quantum enhanced Web3 application. Right. So here we have the login providers. So in this demonstration case, we're going to use Firebase, but it can be any custom authentication or any social login provider. Once we authenticate the user, then we're going to generate the ID token, and we're going to check whether the user is logging for the first time or not. Let's say if the user is logging in for the first time, then in that case we're going to take the random entropy from the QRNG, and then we're going to generate the account, and then we're going to pass it to the Web3 auth, which is going to split that into three shares. One would be an OAuth login share. OAuth login share can be accessed only once the user is logged in, and this share is stored in a decentralized distributed network, in which case nobody has access to the account or nobody has access to the share. And second would be device share, which is stored within the device from the device which is being logged in or created. And then the backup factor key. So this is a backup factor key which can be stored by the user, and you can consider it as a multi-factor authentication as well. Let's say whenever we want to authenticate the user again, then in that case we can also ask the user to input the backup factor key. And why we choose quantum dice? And here we don't want to rely on the mathematically derived randomness, so that's the reason we're trying to replace that with QRNG, quantum dice QRNG. And second thing would be in terms of verification. So whenever we generate random bytes from the QRNG, we're trying to continuously verify the randomness score. Yeah. So this is the difference between traditional Web3 wallet and then quantum enhanced wallet. So first would be randomness. So in general wallets, we're going to get the randomness from a software random number generator, PRNG or OSPRNG. And in our case, we are trying to get it from the QRNG. Yeah. And when it comes to recovery, right, in normal traditional Web3 wallet, you need to have the 12-word seed phrase, only then you'll be able to recover. But in our case, we'll be having a social backup factor key. You can use and probably can add a couple more backup factor keys for you to recover the account. And the onboarding. So in traditional, Web3 wallets, it's a little bit complex. At the same time, you should be aware of the technical terms like networks, gas fees, and these things. But whereas with in our wallet, it will be a simple social login. So you don't have to, remember the 12-word seed phrase. At the same time, you don't have to understand more about the networks and everything, because these things are already taken care of with the application itself. Yeah. So who's going to be using this wallet? So one would be developers, let's say, who wants to onboard regular or traditional users to the blockchain for their application. So it will be easy for them to onboard just with email and password. Let's say in traditional, you will be having a separate applications like MetaMask, a mobile app, probably in Chrome extension. So which means whenever somebody wants to log in into the application, they need to have a separate extension or probably separate mobile app like MetaMask and all. But in our case, they can directly integrate into the application. So the user don't need to install any external application to manage the keys or to manage the account. And for the institutions, so for the fintech, let's say if they wanted to, implement the same thing across their blockchain, let's say their protected or private blockchain, they can take advantage of this. Let's say, for example, instead of them having a different application, they can enable their work accounts to be a blockchain wallet for them. So why this matters. So we do the first one. One of the first ones, like to integrate the QRNG into the wallet generation at the same time, also to manage the MPC. And so now I'll just give a live demonstration of like how the traditional Web3 wallet works, and then how we're trying to make it much more simpler with quantum enhanced one. Yeah. So this is how the traditional MetaMask looks like. And let's say whenever I want to create a new account, and then so I need to input a password, and again this password is stored locally, so you don't have a centralized database where the passwords are being stored. These passwords are stored locally, and like so once I create the password, so this is the 12-word seed phrase which will be generated. So this will be used as a backup factor key. Let's say whenever you want to log in a different wallet, or probably whenever you want to recover it, then this is the 12-word seed phrase which is supposed to remember. Let's say if you lose access to this, then there's no way to recover, and at the same time, if somebody gets access to this thing, then which means they can exhaust the entire account, right? So to show it like, okay, 12. So once I'm done, then this is done. Yeah. So this is how the traditional Web3 wallet looks like. So you can see the couple of steps which I need to follow. One, I need to have a password, and then again I need to store the backup factor key, then I need to re-verify it, and then I'll be able to get the access to the wallet. So in this case, you can see there are different networks like Ethereum, Solana, and all the EVM compatible networks. So as a new user to the blockchain, it will be very difficult for you to understand, okay, what is gas, what are networks, and at the same time, what is seed phrase. And a lot of people might misplace the seed phrase, right? So in traditional, in comparison to normal traditional wallet, let's say if I use the traditional one, so in this case I'm using an email password, custom email password, but this can be replaced with any social login, let's say Google or Microsoft. So I input this. Yeah. So when I'm trying to input, maybe I'm going to check in the behind the scenes, okay, if the user is new, then in that case I'm trying to get the random entropy from the QRNG, and then random entropy from random bytes from the PRNG, and then I'm going to generate the keys, and then I'm handing it to the Web3 auth for the MPC to split into 3 different device shares. Right. So now when I get the key details, okay, these are the key details, and then this is the account which is being generated from that QRNG, and this is the balance. And let's say, for example, if you want to generate a 12-word seed phrase, now you can see that this account is being generated within this application, right? Which means this particular Ethereum account or blockchain account is linked to this particular wallet. And let's say if I want to use it this with any other traditional MetaMask wallets, then in that case I can also generate a backup mnemonic as well. So you can use this, and then you can import this to the MetaMask wallet as well. Let's say if you want to use the same blockchain account elsewhere,